Forget record here. Who do I have online? How to sound check? Who can help me? Is Kasia here? Hi Kasia, are you here? Hey Kasia, not here. Hey Jingqi, you can help me. Jingqi, can you hear me?
Hi. Yeah.
Oh, okay, yeah, yeah, yeah. Can. Thank you, thank you. Okay, wanted to sound check and make sure you can. Okay, music back on. You can take one just. Back on. Right. 是吗？It's a diagram. 啊？有翻译本吗？737. Kara! Okay. Oh, I think forgive me, okay. But I was scrolling through my pictures, then I saw Karen. Legit. Are you sitting in front? Okay. Wow. Ah, 10 people online already. Wow, not bad. Wow. But 739. I will start very, very soon, okay? Chinese. Okay, sorry, nice to take over. It's me. Okay. Welcome everyone. If you are non-overmark students, welcome to this center for the first time. If you are an overmark student, I think you are like super familiar with this environment already. Okay, so let me turn on the neon light at the back. Okay. Can you turn down Okay, anyway, warm welcome to everybody. Thanks for taking time off. I think you all are super busy with your WAs that's going on now. I heard from some people got SSWA tomorrow, but still here for Sec 4 chemistry. Okay, because honestly, Sec 4 SS can study or not? Okay, kidding, can. Okay, so it's propaganda. No, okay, it's not propaganda. It's very, very good that we love Singapore because this session is recorded. You cannot say the wrong things, guys. Okay, if not, we will begin with a little bit of a sharing of myself first, okay, before we jump into the real camp stuff. Okay, for those who already know me, you bear with me a little bit. You might have seen this like three times, four times, a lot of times already. Okay, anyway, my name is Gerald. I just felt that it will be weird if you go through these 2 hours without knowing my name. Okay, I will try my best to know all of your names. But of course, forgive me for not remembering your name out of this session here. Okay, anyway, my name is Gerald. Okay, and I teach both chem and physics at Overmark. And I teach for about 9 years already. So took O levels like quite a number of times, leading to this year again. Okay, so proud to say above 95% of my students get A1, A2, or B3 at O levels. Okay, so this not intending to break this trend here. Okay, but you know that O levels is most of the time like a little bit easier compared to prelims. Okay, but it's getting less and less true every single year. Okay, if you all try the TYS already, it's getting harder and harder. Okay, so that's why we need to break down questions very effectively. Okay, anyway, about myself, I don't just teach and teach and teach. I also play floorball since secondary school days, and I used to busk on the streets. Okay, so those who stay at Ang-Mo-Kio, Ang-Mo-Kio side, I don't know whether you all go Ang-Mo-Kio Hub. Okay, but I used to busk at Ang-Mo-Kio Hub. Okay, maybe don't never pass enough times for you to see me there. Okay, but my license is finished. It's too tiring to lug my speaker all the way then sing for 3 hours and assume that people are listening to me. Okay, but I enjoyed the process there. Okay, so it's a video that nobody asked for, but I will just play it for all of you to cringe. Come, this is Ang-Mo-Kio Hub. Sorry to my students, I think I showed you all this before. Anyone know this song? Yeah. Okay. The chorus. Okay, I forget it. Okay. I know some of you are cringing a little bit already. Okay, but this was me, or this is me when I'm outside of teaching. Okay. Anyway, I'm a Doing Sen Chinese TikTok songs fan, football fan as well, and I love Asian food. Okay, so if you are a foodie, also can hit me up. Okay. Anyway, I'm currently grooming a 3-month-old to be a human being. Okay. At the same time, I'm still teaching myself to be a human being, but this is who I'm grooming. This one, this small one. Yeah. Anyway, she's still 3 months old and trying to figure out how to be a human being. Okay, but the world is tough. I know y'all at Sec 4, y'all know how tough it is. Okay, but she after 16 years will be at your position now. We shall see how she does. Okay, anyway, enough about myself. Just if you don't remember anything, right, just remember my name. Okay, if you need to ask anything, raise your hand. I try my best to address on the spot. Okay, but there may be certain questions that I may discuss with you after 9:30. Okay, and if not, let's go to this. Anyway, on your table, you should have this already. For people joining online, you should have a copy of this right in front of you. Okay, no matter whether it is soft copy or hard copy or anything, okay, this in front of you is going to help you a great deal. Okay. So this is the nice looking cover page. Okay, just as an intro, right? Okay, to set things straight for these 2 hours, right? Don't be too obsessed with copying down the answers. Okay, you need to be obsessed with how we approach all the questions. Okay, so I have the answer key like ready for y'all here already. And y'all know you click on the Google Drive thing, you can download this whole thing also. Okay, so physical students will get this. Online people, you can click on the link to get the answer key. So don't be obsessed with copying down the answer. Things that you should be writing down is, next time I see this exact or a similar question like this, how am I going to approach it? Okay, so this should be your goal for today. Okay, if not, we jump straight in. There are 3 topics that we are covering today. It may not be your WA topics for next week or next week. Okay, but are these topics tested for O levels? 100% yes. Okay, and there are certain questions that I personally feel will come out for O levels. Okay, that's why we are including some questions inside here. Okay, we start off with chem energetics first. For some people, it may be a set 3 topic, I don't know. But some people maybe just learn this topic. Okay, we have energetics, electrochemistry, and ammonia. These 3 topics. Okay, of course, you know, most probably your school ammonia is SLS. I don't care, you're just going to study on your own. Okay, if time allows, we will go through a little bit of that, not intending to spend too much time on that. Okay, if not, we jump straight into chem energetics first. If you turn into the first page, chem energetics, there are a few blanks for you to fill in here and there. Okay, so follow along. The blanks are, I'm not going to show you the answer immediately, like let you copy down or anything. Okay, but what you need to be thinking is, as we go through along, you should be revising really. Okay, so don't treat these 2 hours as, oh, I come and learn a little bit, then I go home still need to piang very hard. Okay, along the way, you should be like, oh, I am revising and recapping already. Okay, so this should be about 40 to 50% of your revision done. Okay, if not, let's go. Chemical energetics. Okay, endo and exothermic. The easiest way to remember this, right, is the following. Here. Endo is heat enter. Wow, exotic. Okay, heat enter. That's why EN. Exo is heat exit. The people who don't do well in this topic, they fail to understand the difference between the system and the surroundings. Okay? Later we will talk a lot about it. Okay? But in general, this is what we expect first. Energy is absorbed through blank bonds. Okay? In your head, you should be thinking and already knowing the answer. I slowly review one by one. Energy absorbed to break bonds. Okay? This is what endothermic reactions are going to be about. And exothermic reactions are when bonds are formed. Okay, if you like, Joe, this one I always like mix up and cannot remember how. Here, I help you with this one. Okay, so this one my students will be quite familiar with this. Okay, exothermic bond forming. If you have this very chill girl or like very handsome guy in school, then by then Sec 4 levels, like, I don't want to like commit myself too much. So levels, then you confess. And you shot each other. Fireworks. Why? Because you form bonds with that guy or girl. Fireworks. Boom, 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 boom. What does this mean? Heat being released. Exothermic reaction when you form bonds. Okay. Endothermic is when you super angry, absorb energy, you break the ice popsicle. Okay. I don't know whether you all ate this thing before, but it was my entire childhood. Okay. And I hated when I had to bite it off. Use scissors and cut the tongue. Okay. Point is, you use energy to break. Absorb energy to break bonds. Okay, so this is a super effective method that I've used for many years if you struggle to remember most of the time. Okay. As well, you should be starting to think, energy absorbed to overcome what? Overcome forces of attraction. Okay, so later we will see some exo and endo reactions. I don't want you to hardcore memorize. There's no point. Okay. Overcoming forces of attraction, recognize this fact, same thing. Absorb energy to break. Okay, forces of attraction for exo therefore becomes stronger. Okay, the notes wise, you should be obsessed with this. Answer key is not going to provide this, so you should obsess over this and ensure that you understand everything. Okay, next part. Process or reaction is exothermic or endothermic when this happens. Okay, this one, a lot of words inside here. Okay, to summarize this up, I like to call it BB and BF. Okay, to summarize, delta H is BB minus BF. We'll see this again on the next page, but I want you to recognize this first. Okay, and the best way to remember this is always put your BB before your BF. Okay, even though you got boyfriend and already, put your BB first. Okay, so bond breaking minus bond forming. So that's good. So this chunk of words here, I know it's very hard to read. Okay, break bonds more than form bonds. Therefore, this is BB more than BF. Overall, I absorb energy. Okay, in your head, I think you should register this idea. It should be endothermic. Okay, use the idea of delta H is BB minus BF. If my breaking bonds is larger than my bond forming, my delta H equals positive. Okay, the other side, I won't talk too much about it. Okay, but similarly, chunk of words here, recognize that BB is less than BF. To emphasize, BB stands for bond breaking, BF stands for bond forming. Overall, I release energy. This is exo. Okay, this is notes wise only. Later, we'll be trying questions ready. Okay, so you have this ammo ready to fire at the questions. And we will break down exactly what I feel may come up for your WA if you are tested for this. Okay, and certain concepts that you really need to register and know. Okay, let's think about this. Okay, if you struggle with this entire topic, you don't understand what is the difference between system and surroundings. And often schools don't emphasize on this point enough. Okay, what I want you to imagine is box. Okay, my drawings sucks. I'm sure you all can draw a better cube than me. Okay, so inside this box, the thermometer can never ever enter this box. What do I mean? This box is known as your system. Whatever is around the box, outside of the box is known as your surroundings. Okay. So the best way to visualize this is the box is completely sealed up. The system inside consists of your reactants and products. Can my thermometer ever go into the box? Never ever. Therefore, thermometer can only measure surroundings. Okay. This is thermometer. Forgive my drawing, okay? This is your thermometer. Thermometer can only go into the surroundings. Therefore, whenever it is exothermic reaction, it exits the system. You expect the surroundings to become hotter. Okay? I know it's very counterintuitive for some of you if you don't visualize in this box sense. Okay? Because it seems that my chair tell me exo temperature supposed to increase. Then chair tell me enthalpy change supposed to be less than 0. Okay, then these two don't match up. Okay, so if you feel that it doesn't match up, you are mixing up the system and surroundings. Okay, so all in all, just know temperature is measured. The thermometer can only measure surroundings. Okay, the enthalpy change itself is about the system. Reason why delta H is less than 0 for exo, because the system, the box itself, gives out the heat. Temperature of surroundings increase as a result. Okay, so overall energy of system drops. Okay, in your notes, if you are someone who hates words, you should be writing arrow up, arrow down, less than 0, all these kind of things. Okay, so you don't need to write everything that I put here. Okay, anyway, the recording will be provided as well. Okay, if you don't manage to catch up or write certain things down, you can always view that. Okay, endothermic will be on the other hand, same. Okay, temperature of surroundings, we expect it to decrease. Some of you don't understand this, again, because system and surroundings mix up. So it's the system absorbing the energy to break the ice popsicle. So temperature of surroundings, we expect to drop. Energy level, we expect to rise. Enthalpy change, more than 0. Okay, so this is a super quick breakdown of the entire chapter, and I feel this box idea here is the most important part really. Okay, for my students, you all will know these common examples. I call this the 5 5s. Okay, we need to know 5 examples for exo, 5 examples for endo. Again, I don't need you to hardcore memorize this, but there are 2 more that I want to add to your notes. Okay, and I think your notes have some blanks here. So E for endo, there's electrolysis, where I absorb electrical energy to break down compounds. All in all, the examples, I say don't hardcore memorize because make sense of it. Thermal decomposition, absorb energy to break. Photosynthesis, absorb energy to make food. Electrolysis, absorb energy to break down the compound. Okay? So it's never about forcing all of this into your head. Okay, but there's one more that we didn't include here. In your head, you might have this melting, boiling. Okay? If you are thinking with the idea of, I always need to think about the temperature when I consider whether it's exo or endo. Throw that out of the window. Why? Melting sounds hot, boiling sounds hot. Then you feel that it's exo. Correct or wrong? Wrong. Why? Because melting and boiling is absorb energy to break bonds. Therefore, endothermic. So think in terms of energy, don't think in terms of temperature and okay? Whoa, good question. Very good. Hi, do you screw up? Oh, this one at the end of it, I do that for you, can Gwen? After 9:30, I scroll through the whole thing for you to copy down everything. Okay. You gotta take picture of my face also can. Ah, okay, thank you. Okay, so for the exothermic reaction, combustion and neutralization, very common, very normal. Neutralization, I want you to visualize this in terms of H plus OH minus become H2O. This is like your crush hug each other. You are the H plus, your crush is the OH minus, you hug each other, fireworks explode, boom, 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 exothermic. Okay, so form bonds is always exo. Okay, there's one here that's missing that I want you to know as well. This is the displacement of metal. Okay, my students will know this as well. Displacement of metal is about more reactive boyfriend take over the place of less reactive boyfriend. Okay, and it happened to me. Therefore, I angry, exothermic reaction. I release my energy. Okay, so it resonates with me well. Okay, so if you cannot cheat her or like your girlfriend don't like you back or boyfriend don't like you back, you may find this very relevant for you as well. Okay, anyway, these are the five fives. This condensation and freezing, please group them together to remember as one. Okay, because I am forming bonds. Okay, that's all for the first page. Wow, we need to speed up a little. Okay, but going on to the next page, this delta H here. This one we already went through. I won't jump into each of the lines here. What I want you to recognize is simply this once again. Delta H, put your VB before your BF. Okay. I may spoil some relationships today, I don't know. Okay, sekali the girlfriend boyfriend here, then I don't want to put my boyfriend first really. Yeah, sorry if I do, okay. Okay, so put your VB in front of BF, delta H. Later, we'll do some calculations. Energy level is pretty similar to energy profile, but without the curve thing. Okay, so you don't draw in the activation energy, you only show the start energy level of the reactants and end level of the products. Energy profile is the one that I'm more interested in. Let's label the delta H and activation energy together for this. Okay, I give you 20 seconds to try to label in. I'm quite sure you're going to get it right. Okay, but there's something that again schools don't really talk about that I want to add on. Okay, give this a shot. I usually don't resort to this, but I'm resorting to looking at my watch to really give you 20 seconds. I usually say 20 seconds, but I give you like one minute plus. Today, what really cannot. Okay, but later there will be chances for you to try certain questions. Okay, but same thing won't give you too much time. Okay. 20 seconds up. Okay, I'm sure many of you understand this. Okay, so delta H for endothermic, upward arrow, activation energy, note for yourself, is always, always, always positive. Okay, so if you ever draw activation energy as a downward arrow, or worse still, double arrow, gone. Okay, activation energy is always from the reactants up to the top of the curve. Okay, sorry, my line not very straight, but you get my idea, right? Okay, so it's always from reactants up to the top of the curve. So for exothermic, likewise, reactants to top of the curve, delta H will be downward arrow. Okay, many of you can recognize this. Something that schools don't really talk about is actually activation energy is not just what you see as EA. I want you to be able to see this as BB. Activation energy is also bond breaking. Activation energy is bond breaking. I am breaking bonds in my reactants. Then from there, I form the bonds to form my products. Therefore, your BB is your activation energy. Your BF is actually from the top of the curve down to your product. Top of the curve down to the product. Are you okay? You just take a life. Huh? What is that? Oh, okay. I think someone brought the bug in here. It's not this center, not okay. This center very true. Okay, please put it into your rice. Huh? You're still alive, huh? And what are you going to do with it? If you start to fly, I'm running out of here. So, okay. let's just pretend that it's not there. You shouldn't have told me. Now you're making me very conscious. Now every time I want to look there. Okay, anyway, this is the energy profile diagram. And if you are tested for this topic, quite sure that they are going to ask you to draw. Okay, and there are some MCQs that are quite tricky. They will ask you to label the BF, label the BB, know this for a fact. Okay, because this is something that textbook don't write. Okay. Catalyst wise, apart from these three, I think you are familiar with this. I also need you to know one additional point. Okay, use of catalyst not only speeds up the forward reaction, it can also speed up backward reaction. Can also speed up backward reaction. Backward reaction. Whoa. Backward reaction. If you don't understand my handwriting, you let me know, okay? Backward reaction, activation, energy also becomes lower. Okay, and this is something that people don't recognize. Okay, can also speed up backward reaction. Bracket backward reaction, activation energy drops as well. Okay, backward reaction, activation energy is here. If I take a look at the energy profile diagram for endothermic one, okay, the activation energy for backward reaction is this orange color. This is activation energy for backward reaction. If catalyst can lower the curve, activation energy, the orange color one, will also come down. Okay, so I'm not really interested in what the textbook already tells you, okay, because everybody can read through the textbook. Okay, but this is something extra that questions are like sort of like low-key expecting you to know. But then during exam, you're also stressed. Then you still need to think of all these things. Okay, so this is how we can like ready ourselves for all these different scenarios. Okay, hydrogen fuel cell. I'm not going to elaborate too much into this. Someone was telling me that it's back to Horn curve. Unfortunately, it's my student. Okay, and she says that this haunts her every single time. Okay, this hydrogen fuel cell, you look outside now. How many hydrogen powered cars can you find? Not a lot. Okay, and it's not our fault that we are killing the earth. Okay, it is just too damn hard to power a car using hydrogen. Okay, because the hydrogen is super hard to transport. So the whole hydrogen fuel cell, the disadvantage here, I want you to recognize whenever there's gases involved, it's always damn hard to transport. Okay, but of course, the good thing is, in the whole hydrogen fuel cell, the whole idea behind it is, I take hydrogen, I take oxygen, I produce a product that is not harmful to the environment. Okay, and I'm sure you all know this, water. Since water is produced, it doesn't harm my environment. Therefore, it is a good alternative. Okay, but it's too damn hard to do this, to transport the hydrogen gas around. Okay, acidic electrolyte. This one, don't worry too much. What you need to know is alkaline electrolyte. And this can be found in our creator notes as well. Okay. I won't elaborate too much into this. Okay, but what I want you to be able to see and recognize, right, is we have a super standard equation where we electrolyze OH minus. When we electrolyze dilute sulfuric acid, always at the anode, we keep seeing this. I know you read this until like you low-key already damn sian. If you all recall this orange color, it is not related to this hydrogen fuel cell, but what I want you to see is this is actually the opposite. The opposite of what you have been always writing and writing, right? If this is going to cut down your starting time for hydrogen fuel cells by. Okay, and this is actually a reduction. Therefore, this is my cathode. This occurs at my anode. Why do I know it's anode? Hydrogen gets oxidized. Oxidation state 0 to +1. Oxidation. Therefore, this one confirmed anode. Later electrolysis, we will talk about two animals that we keep in mind to understand the whole of electrolysis. Okay, but we keep that to a while later. Okay, that's about it I want to talk about for hydrogen fuel cells. Okay, I don't intend to go into specific hydrogen fuel cell question. Okay, there are certain questions in this chem energetics that I want you to be able to bring to the WA. Okay, we take a look at question 1 first. I will give you 1 minute approximately for each MCQ. Okay, but we go one by one instead of have you try all at the same time. Okay, you take a look at question one. Question one, I feel don't even need 1 minute. I give you 30 seconds for this question. Okay, this one, if you know the high five, you must know this. I feel damn bad, but I'm looking at my watch to really time you. For those joining online, try your best not to refer to the answer key yet, because I feel that undermines what you could be thinking about. Okay, I already printed the answer key. Should I pass to your contemplator about it? Most likely, as a student, what I will do, I put the answer key beside here. I do. Okay, most likely that's what I will do. Okay, so I feel I shouldn't ask you first. Okay, 30 seconds is up. Correct answer for question one, as simple as option C. Did you get this? Okay, something that some people won't recognize, okay, is I don't know what this thing is. Actually, what this one like look damn weird to me. Okay, this is nothing more than hydrogen atoms times 4. This is nothing more than oxygen atoms times 2. So what did I do from here to here? I break the bonds. Okay, like the ice popsicle, I break the bonds. Okay, that's why reaction number one is endothermic. I absorb energy, then I eject. Okay. On the flip side, number two, you should already understand this. Atoms come together, form bonds like your crush, exothermic, boom, 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 fireworks. Okay, so 2 and 3, exothermic. If you want to elaborate too much on this, question 2 is where you put your calculations into use. Okay, so you should have a calculator beside you. Okay, now I know handphone even got scientific calculator, sure. Okay, but you need to have this in front of you. And if you hate the plus and minus stuff, later I will tell you exactly how I want you to present your working. Okay, take a look at question 2 first. This one, you get 1 minute to try this. Those who are not sure where to start on, I will be dropping a bit of hints here and there. If you don't require them, don't need to look up. Twenty more seconds. Okay, time's up. Okay, sorry that I have to interrupt some of you. I know some of you like, I'm really very close to you. Give me some time to recognize the answer, to find the answer. Okay, if you can find the answer, great. Okay, please continue to do so. Okay, but the correct answer for those who are done, correct answer is A. Okay, and exactly how I want you to present your answer here, right? Okay, I feel that this kind of question will come up for WA if you are tested for this. Okay, and some questions will resort to asking you to calculate the bond energy instead of calculating the enthalpy change. Later we have a question on that. Okay, but if you are like me, you don't like the minus minus equals to plus, then what minus plus, then minus. Okay, if you are like, wow, don't really like math kind, okay, put them into square brackets to help yourself see this very, very easy. What do I mean? Delta H is BB minus BF. Put your BB before your BF. The whole BB put inside a square bracket. Minus BF, whole thing put inside a square bracket. with that, you don't need to deal with the minus plus equals to minus, that sort of shit. Okay, what do I mean exactly by this? Here. Okay, so if I can erase my working here, I try to save some time here. Okay, this is the first square bracket for BB. Okay, if you can draw the structural formula out, this is simply primary school already. Why? I'm counting how many bonds. 1, 2, 3, 4, 5, 6. Okay, so I have 6 of the CH bond. I have 1 CC bond. I have 1 CL bond. Okay, so BB I put inside a square bracket. BF I put inside a square bracket. I key each square bracket into my calculator. I know most likely you all like to store A, store B. Do that. Store A, store B, A minus B, you get your enthalpy change. Okay, then you don't have to deal with the plus minus equals to minus, this kind of things. Okay. Answer for this, A. So again, one what's that? CH one, right? 600. Only one more to down. Another that like only that one student, one score. Your observations is damn good. Okay, but I damn scared when my students do this. Why? Because you may count wrongly. Okay, in short, your method is definitely okay. You saw which bonds are broken, you just go and feed them accordingly. Okay, so long answer short can. Okay, but advice don't. Okay, because why? In a structured question, they will award method marks if you calculate out this whole thing. Method marks for this whole thing. Okay, so if you see that bonds there, a bit risky. Okay, but if you get the answer, who can tell you? Okay, question 3. Question 3, 30 seconds for this because not much calculation involved here. Then we will move on to structured questions. Exciting really. Activation energy for the reverse reaction. We just talked about this only actually. I think some of you will answer it. Right, you got answer already. You got answer already. Very fast. I was just really you do that fast. I give 1 minute, you 30 seconds again. Okay. Activation energy for the reverse reaction, backward reaction. As I said, it's always from the reactants up to the product. Sorry, up to the tip of the curve. Okay, so for this case, reverse reaction will be from here. So it's just this. Okay, so if your answer is ever negative, confirm wrong. Okay, so activation energy is always positive. Answer should be D. Okay, so the easiest way is go and draw out the arrow for yourself to see first. Once you can draw this arrow, you win already. Right. Extension question. What is the enthalpy change of the backward reaction? Okay, some of you already got answer. Very good. Okay, I know you are looking at this already. This one, just flip around the sign, you got it. Okay, so backward reaction will be exothermic. This is endothermic. Let's go. Question 4. Okay, I won't let you try every single question. There are some that I want to discuss more intensely with you. Okay, so we take a look at the breakdown of the question together first. I don't want you to throw you structured questions, then you just try everything on your own, then we discuss. Okay, I want to break down questions together. Okay, but if you then Garangan want to go ahead to like break down the question for yourself, sure. Okay, this question is not difficult. I have liquid hydrazine, combustion chamber, produced water, and nitrogen. Okay, the first part, give this a shot. I highlighted the things that you need to take note of. How do I write down the equation? I gave you the reactants and products. Okay? I gave you the hydrazine. Water and nitrogen are the products. But there's one reactant that's not so obvious. Can think about it for 10 seconds or so. Won't give you too long. Okay. Keyword here is combustion. Okay. Combustion, therefore, is going to be about oxygen. Okay. Whenever you approach a question, again, don't be obsessed with the answers. Be obsessed with the breakdown of the question here. combustion, oxygen should come to mind. Whether I have enough or not enough, that will determine whether it's complete or incomplete. Okay, but whatever it is, combustion is going to have oxygen. Therefore, hydrazine plus oxygen is going to produce nitrogen and water. Exactly what the question told me. Expect this kind of questions where you totally don't know what kind of reaction this is. Okay, but question told you exactly the reactants and products. Okay, moving on. For part B, calculating of bond energy of the NN bond. Okay, I shall not allocate time for this, but rather I need you to be able to convince yourself. If you see this exact or similar kind of question in exam, draw out the structural formula first. Why? Because if you don't draw out, a lot of people will make mistake in 2H2O. Okay, and I've seen this too many times already. Okay, personally myself, I'm tempted to write 2OH bonds. How do you make sure that you don't? You draw out the structural formula. You go back to primary school, you count 1, 2, 3, 4, how many bonds? Exact. Okay, after drawing out the structural formula, then your only job left will be tell yourself reactants, bond break, product, bond form. Delta H, I put my BB before my BF, I solve for bond energy, and single bond N. Okay, this is the kind of question that I was saying, that they don't ask you to calculate enthalpy change, but they give you the enthalpy change. Then they ask you to calculate the bond energy. Okay, whenever a question like this comes up, use algebra to help yourself out here. Okay, I'm going to review the answer to this. Okay, sorry that I'm not allocating time for this, but you can take this down first. Okay, that the bond energy will be 113 kilojoules per mole. Okay, the answer key also will have this as well. So again, be obsessed with, am I able to draw out the structural formula? Okay. So the algebra that I want you to see here, for those who hate algebra, if you hate math, you might hate this even more. Because now you are coming up with an algebra equation on your own. Okay, so if you are a big hater of x, you're like, wow, find x, myself, I go and die. Okay, if you hate to find x, it's okay. You can write down n bond also can. Okay, but you need to know exactly how many n bonds I have that I'm trying to break or I'm trying to form. In this case, break. Okay, so my advice still stands. Do I want you to write in square brackets? Definitely yes. BB write in square brackets, BF write in square brackets, minus that, done. Okay, the next part. The next part is also a question that usually follows suit from this. Okay, this mark allocation here is 1 mark. It can range from 1, 2 marks, or even 3 marks. Okay, and analysis of like prelim papers from last year as well as TYSR, there's always a mix of different answers that different schools are giving. Therefore, the best way to like cover your backside is you write the answer that gives you 3 marks, no matter the mark allocation. Okay, and exactly what do I mean by this? A lot of people, a lot of your friends I feel, in terms of bond breaking and bond forming, confirm can write. Maybe they write energy absorbed because energy absorbed less than energy released. Then expect to get the full marks. Cannot, because you didn't elaborate on exactly what the question wanted you to do. Okay. Again, don't be obsessed with the answer because the answer key has this thing that's given to you as well. But I need you to be obsessed with the 4 steps to answer questions like this. Number 1, think about the BB. Think about the bond breaking. Bond breaking is always energy absorbed. Bond breaking is always about my reactants. Second, think about my BF. Okay, so same thing, I put your BB before your BF. BF, I talk about energy released. I talk about my products. Okay, I'm sure your schools may be going through a lot of questions like this, but you keep seeing this like answer again and again and again and again. Are you able to replicate this off? Okay, if you know these 4 steps, it's going to help you out a lot. Compare. Conclude. Okay, I'm going to color code them now. BB is the yellow color in the answer. BF is my green color in the answer. Compare is the blue color in the answer. Conclude is the pink color in the answer. Okay. Recognize the structure to answer questions like this. Okay, sorry, this one more of NN bond. I don't know why, but I need to click in order for you to see the triple bond. Okay, so the second line, the N triple on, the N triple N bond, I need to click in like that. Okay, so answer it based on this. For exothermic reaction, immediately in your head should be, exothermic, therefore BF more than BB. Energy released when I form bonds is greater compared to energy absorbed when I break bonds. Okay, or you phrase it another way, works as well. Okay, like my answer here. Okay, so know this way of answering going forward. Okay, I won't discuss the similar questions like this anymore. Okay, but this is how you can like study more effectively, I feel. Okay, no matter how many times you read your textbook, I feel you may not get this question. Okay, let's go. This one, energy profile diagram. Okay, what? This one, I think I don't review the answer first. Okay, if you are done with the DAE, give the drawing a shot. Okay, because that's what I feel you will need to do. And some of you may make these minor errors that I will highlight. Okay, so part C, I give you approximately 1 minute to try to sketch out the energy profile diagram. Okay, one question, very good. How do you know that it is 1 mole and 4 mole? Oh, Nian, thank you. Okay, so the 1 mole and 4 mole came from my drawing of the structural formula. Okay, so thank you for bringing this up as well. Okay, so my answer of getting all 3 marks is you need to quote the exact number of moles of bonds. So the question is, how do I find it? NN bond, I see in my structural formula, I have 1 of it. Okay, if you can follow back to my structural formula, it's here. Okay, the rest, if you are okay already, you can try the activation energy diagram. Okay, 1 mole of NN bond, 4 moles of NH bond. I count 1, 2, 3, 4. 1 mole of OO bond, 1. Okay, see the logic already? So that's why I advise you to draw out the structural formula first. 1 mole of NN bond. The OH bond is the trickiest because I need 1, 2, 3, 4. Why did I draw H2O 2 times? Because I have 2 H2O. Okay. Around 20 more seconds for you to finish up energy profile. Okay, and I will highlight things that usually people will miss. All right. Does that answer your question, Nian? You can hear me, huh? I didn't want to just talk to the air. Okay, sure. Hey, by the way, it's Cassia here. Ooh. Oh, okay, no problem. Okay, never mind. I'm supposed to like call out your name, Cassia, because your friend like uh your friend said I cannot say her name. She asked me to look out for you. Okay, so hello, Cassia, if you are here. Okay, energy profile diagram should look like the following. Exothermic, therefore it must be downward arrow for delta H. Again, check for yourself here. Okay, I would love to check for everybody, but I think I will take 5 minutes. Activation energy, ensure that you didn't draw this. Okay, I'm very worried because you all are looking down, looking up. Sometimes you don't know what I'm saying. Okay, so don't draw this. Okay, this should not be drawn. Check for yourself if you do that. Activation energy upwards from the reactant level to the top of the curve. Okay, common mistake that I see is delta H going all the way down. Check if you did the following, all the way down to the x-axis. This is incorrect. Okay, things that people tend to miss out are this. upward arrow, downward arrow, progress of reaction, labeling of the reactants and product. Okay, this O2 should be in gaseous state. Okay, if you are always wondering, should the delta H need to label the exact value or not? Should. If you have the value, label it. Right. Next one. Do you all see this as question 6 or question 5? In your paper. 5 is it? Okay, so this should be your question 5. For organic chem people. Okay, you going into WA, you need to know this instead of relying on the info presented to you. Why? This is substitution reaction, right? An alkane reacting with bromine or chlorine under the presence of UV light. Then I substitute the atom inside. Then I pull out the other atom. Okay, it's like pulling out the H, jump in the Br. Okay, that's why I get a C2H4 Br2 as well as a HBr. Okay, bond energy provided here. Okay, for part A, same thing. I won't give you time to try this anymore. Okay, I feel that this should get to a point where it is very, very standard, and when you go into exam, you see this kind of question, you feel like jump for joy first because you confirm know you can get a box. Okay, so the enthalpy change for the reaction again should be the following. Okay, in the questions that we have seen so far, the structural formula has been given to you all. The previous one I drew out, so you could like count quite easily. Okay, but in the event that they don't draw it out, for example, a combustion reaction, really recommend you to draw it. Okay, so for this, if they give you the structural formula, all you need to do is count. Okay, so again, your only thing to remind yourself is I am breaking bonds in my reactants, I am forming bonds in my products. If you know BB minus BF, confirm plus short, you can do this question. Okay, so sorry about this. I won't allocate time for you to try this out here. Okay, but again, what I want you to recognize is put them into square brackets. It looks like a hell lot of numbers here. Okay, but you are going to be able to write the exact same things if you see the same structural formula and you count correctly. Okay, my concern is if your equation includes mole ratio, for example, 3:2, remember that you need to draw it out either 3 times or 2 times, depending on how many there are. Okay, so again, don't be obsessed with these numbers here. The answer key should have has this as well. But what I want to remind you again is the following. This one. Why did I even bother drawing out the H2O twice? Because I have 2 H2O. Okay, so this is a potential careless mistake that you may make. Okay. So for this, the answer should be exothermic negative 43 kJ per mole. Okay, the units for enthalpy change should be kJ per mole. Okay, but look out for what the question gives to you. Because the bond energy is kJ per mole, it should be kJ per mole. Okay. So I don't know whether you adopted the method of, should I like break this bond and don't care about the other bonds? Sure. Okay, if you get negative 43, good. Okay, if you in exam you feel, well, I try this but I always don't get, then you can try this method out for yourself. Okay, may take a little bit longer, but I feel it's worth it. Okay. Part B, to end off our chemical energetics. This is a kind of this is the questions that I feel probably not so standard anymore. When you see this kind of data, then you'll start to panic a little. Okay, so don't worry too much when you see data like this. Find things that are familiar to yourself first. For example, things like bond energy. Ooh, bond energy. I know I'm super familiar with this. And I know the HO bond is the strongest bond. Okay, then I see what reaction conditions with the numbers here and all, 25 become 180 become 300. Seems like I need to heat it up even more and more as I go down to reaction 3. Okay, so a breakdown of a data-based question can look something like this. Okay, think about this for 20 seconds or so. Based on reaction conditions, describe relationship between the bond energy and how readily Paya Lebar air base copper. I hear this in my house every single day because I'm quite used to. Okay. Anyway, so think of the relationship between the bond energy again getting stronger and stronger and stronger compared to how readily it can undergo addition with T. How readily breakdown of the question should be what are the conditions that are actually required. It's getting harder and harder. That's why I need to have higher temperature and higher temperature in order to force the reaction to start. The higher temperature is always up to make the reactor particles become more excited. More excited, then they will run around faster, then they will collide, then they will go and react. Okay? So this one, just think about it. If you're writing down the answer, sure. Okay, but I need you to hardcore think about this. Okay, because these are the kind of questions that usually people give up. Okay, because they see data, they see it really. Okay. Answer to this. Still block, still block. The blank, the bond energy, the more blank it is for the addition reaction to occur. Okay, this is the relationship that the relationship phrasing that you should be putting inside the answer. Because they ask you to describe this relationship. Okay. So I review the first one. Okay, the higher the bond energy, meaning I go down from reaction 1 to reaction 3, it should be the more difficult. Okay, because the conditions are getting more extreme and more extreme. Okay, so part one like this, don't give up because this kind of relationship questions are actually quite easy if you can analyze the data pretty accurately. Okay, after understanding this, I think this will be okay. Prediction of which one has the highest activation energy, meaning hardest for the reaction to go. Meaning the curve that you draw is like super high. Same breakdown as well. In your head, I think you have an answer, either 1, 2, or 3. I think most of you threw away 2 because 2 is in the middle. So it's either 1 or 3. Okay. So again, the reaction conditions that is the harshest, that is the most extreme, is number 3. Therefore, reaction 3 is the most highest, is the highest activation energy. Okay, then the explanation to this will be in terms of the conditions, like what the question wanted. Okay, so most severe, because I use catalyst, I heat to super high temperature, I also put to very high pressure. So the activation energy will be the largest or highest, and will be, of course, the hardest to overcome. Okay, again, I don't need you to be obsessed with this answer key here, because the question that you will face likely will be different. Okay, but how can you bring the data over to the next question that you see? Okay, so the stronger the bond energy, the harder it is for us to break them. Okay, this is what I want you to take away from this question, not about copying down the answer. Okay, so I won't allocate time to copy down anymore. Move on. Okay, I think we are pretty on time. Okay, for physical people here, we have the luxury of having the snacks at the side. Wow, okay, the shelf will be empty. I go and pull out some stuff from bottom. Hopefully still have. Okay, but we are gonna go with about 6 more minutes first. Approximately 8:30 to 8:35. We have a mini break of 1 minute. Okay, I always give this like pathetic break for my students because I think they low-key don't really want to take a break, but they also panting and dying in lesson also. So I always give like 1 minute or less. Okay, but we go on with this first, electrochemistry. From my angle, I see the square as gray color. Then I'm a bit worried, is it you're not seeing colors at all? Okay, electrochemistry here. There will be a comic that I will share with you soon. A comic that I created for electrochemistry. Okay, I think Jinshan and Karen will have seen it before. For electrochemistry, the biggest struggle that people will have is they don't know the differences between each of the cells. Okay, to be very clear cut, if you see on your notes now, I have an electrolytic cell versus simple cell. And we want to try to differentiate this first. Okay, so I'm targeting to like cover as much content as I can within these 6 minutes. Okay, similarities and differences. Even before we jump into each of the boxes, once you see this is like the game, you all play, like, spot the difference. And okay, my mom likes to play the game. You like put the two picture beside us, you like circle which one is different about the two things. Okay, the first thing you should be able to see or you recognize already is simple cells. What am I actually doing? Okay, so it is not like, oh, simple cell is just like another setup to me. It should be in your head. Simple cells, recognize this. Whoops, don't have battery. Therefore, the whole idea of simple cell is I want to create battery. Okay, so that's how we can like straight away recognize a simple cell kind of question. So what's good? Okay, then we go into the words a little. Okay, here I blocked out the words first so that you can like low-key be thinking a little, okay, instead of like copying down. Okay, so again, you should be revising in your head as you are going along. Electrons flow out from the where oxidation takes place. Electrons flow into the where reduction takes place. Okay, in your head, I think you already have the answer. Okay, I think some of you are confident enough to even write down the answer. You are right. Anode, electron flow out from the anode, electron flow into the cathode. Okay, so you see this pairing in the two red words already, which are the two animals that you should be always like dragging along with you as you go into electrochemistry. The two animals are my friends, an ox and red cat. And this is something that will hold throughout electrolysis. Okay, some of you, I think you all are like sort of okay until you reach simple cells, then you're like, wow, shucks, why everything like to balik something like that. Okay, so things that will help you out is recognizing what holds throughout the whole electrolysis. And ox and red cat is something you can rely on no matter whether it's electrolytic cell or simple cell. Second thing that you can always rely on as well, this is number one. Second thing you can always rely on as well is anion always go to my anode. Cation always go to my cathode. Think of them as like shots. The anode and cathode shots. Okay, so this is not my comic yet, but it looks something like this. Yeah. Okay, so if you think of them as shots, right, like there's an anode shot and a cathode shot. Why do I call them as these shots? Because my customers are them. My cation will like go to my cathode shot. Anion will go to my anode shot. Okay, so this is another thing that holds throughout electrolysis. Okay, so the anode, no matter whether it's OH minus, F minus, Cl minus, Br minus, cation, I have a bit more, Na plus, H plus, Cu2 plus, blah, 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 whatever the question is like. Okay, with Cu2 plus being quite famous. So if you are tested for electrochemistry, I feel that they will try to test you for Cu2 plus. Why? Because a lot of people hate writing observations. Right? You all can write the equations at all. When observations come, you're like, wow, blue, fade, more concentrated one, blue, darken. Okay, later we'll see one question like that. So these two things hold throughout electrolysis as well. The selective discharge. What do cations end up doing? Do they get reduced or oxidized? Reduced always occurs at the cathode. So why are we so sure that this always happens? Because even if it is a reactive electrode, it doesn't change the fact that cations will go over to the cathode and get selectively discharged. So this holds throughout electrolysis as well. Reason why we didn't write the selective discharge the selective discharge of anions always occur at the end. This is not true. Why? When I have reactive electrodes, something different happens. Okay, so whenever it is inert electrodes, they can give you graphite, platinum, carbon. These are all inert electrodes. Think of them as a playground for the ions to go and play. Okay, polarity of electrodes as such, simple cell versus electrolytic cell. This is the one that most probably you all are thinking, oh, this is the opposite one. Okay, so true that it is opposite, I rather have you understand why it is opposite. Simple cell is the one that some schools that don't emphasize this enough, then they just tell the students, just think of it as opposite. Okay, whenever you do that, then you are into trouble of not able to apply. In simple cells, best way to visualize is when I have a simple cell, I identify already. Next thing, ask yourself which one is the more reactive metal. A more reactive person, if I have a gun, the more reactive person will shoot. Okay, if you trigger the person will shoot. Okay, therefore, the reactive metal is going to shoot out electrons. Reactive metal, I give an example here. If I have zinc versus copper, this is example only. If I have zinc versus copper, the question gives to me, zinc is the more reactive metal. Okay, I'm sure some of you are tested for reactivity series in your WA as well. Okay, so zinc more reactive than copper, therefore zinc shoots out the electron. I am trying to create a battery in this entire set. Physics students will know this 100%. Negative or positive electrons flow out from a battery or a cell. Always the negative end. Okay, but when we learn DC, okay, I don't talk about physics. Okay, but electrons always come from the negative side. Therefore, zinc with electrons coming out of it automatically becomes the negative terminal of the battery. That's why the other side is just the positive. Okay, so rather than remembering the opposite, because I got one student tell me opposite, but then she told me the wrong thing opposite. Then everything really opposite, her marks instead of getting full marks against you. Okay, so rather than remembering the opposite, understand why it is opposite. Okay. Next, electrodes used. Okay, I don't reveal too much first. Electrodes used for electrolytic cell can either be reactive or inert. This is what I was saying. They can give you graphite, carbon, or platinum. For simple cells, it must be always two reactive electrodes. And they must be of different reactivity. Okay. Later, there will be a question that I want to emphasize on as well. How do we exactly predict the voltage of the voltmeter when they give us some values? Okay, those kind of questions are quite famous and like trending a little bit. Okay. Next, reaction at the anode. Wow, this one covered already, very good. Okay, so selective discharge of blank. Okay, in your head, start to think a little rather than writing everything down that's here. I low-key want to like leave this as blank, then leave you in suspense forever. Then you're like, this one answer correct or not? But this one answer key you cannot find. Okay, obviously I won't do that. So take it. Okay. I think you probably got the correct answer. Reaction at the anode must be selective discharge of anions because that's my customers that are going there. Okay, either that, because we say, I was just saying that it's not always the case that this happens because if the electrode is reactive, okay, reactive electrodes means copper, silver, and whatever. Okay, it may be surprising to some of you at this point because you have learned in reactivity series, copper and silver, we call them unreactive one. Well, then electrolysis, we suddenly call them reactive. Okay, so the difference is they are reactive enough in electrolysis, but in reaction with acids, they are not reactive enough. Okay, so copper and silver are included. So whenever it's reactive, the reactive anode oxidizes. Okay, this is when redox nicely links up with electrolysis because the oxidizing, you should be telling yourself that, ooh, it actually loses electron. Lose electron, then you can form the cation. That's how the anode always oxidizes. Okay, for simple cells, anode must always oxidize no matter what. So after it shoot out the electron, zinc shoot out electron, zinc becomes Zn2 bricks. Let's finish up this page before we take the mini break. Conversion of energy is as such. Conversion of energy, I have a feeling it may not come up for your WA, okay, but we have seen a prelim question that tests this before. Okay, so we chose to include this in here. Okay, so it's electrical to chemical. For simple cell, I'm trying to create battery, so it's chemical to electrical. Okay, but for physics students, I'm sure you all know conversion no longer valid in physics. Okay, so for physics-wise, think of it as transfer. Okay, let's take our mini break here. Okay, I don't do this often, but I'm going to look at my watch for the mini 1 minute break. Okay, for physical students here, if you are dying already, snacks are available to hook you up again. Okay, then toilet is like right inside there. Okay, so we'll take a mini break here first. We'll come back in 1 minute's time for online people as well. Okay, so really time because I'm looking at my watch right now. Okay. Everyone interested in formulas always there. Especially people who are non-overmarked students, I feel like what? Wow. If a student, I'll grab all the gummies and put. Okay. Okay. Uh, snacks. No. Okay. Snacks. You eat too much already. Every week come here twice. I must eat. You take bio. You take physics. Or chem. Yeah, I don't want to. You think we should change up the snacks a bit? Getting sick already. Right? So tell me, why no M&M? If your snack also gonna complain very sad. Okay. Unfortunately, the break is over. But yes, please. Teacher wants some bunny the company. So cute. Okay. Can help yourself to the bunnies, but just don't bring them home. Okay, 1 minute is over, and I'm sure it has been more than 1 minute. This is usually what happens in breaks up. Okay, if not, let's come back here. I'm going to pull you all back here for electrolysis second part before we jump and dive into the questions to try some things out. Okay, so online people, I hope you are back already. Not possible for me to go down the list to like try to see whether you are back. Okay, but welcome back. Okay, to the second part of the lesson here. Hey, don't bring home. Kidding. Please have yourself. You can give them names, then you let me know what. Okay, second part about selective discharge of ions in aqueous solutions. Okay, this is the part where the customer VIP list comes in. Okay, so this is the part where I will show you my comic. Okay, try to make sense of the comic a little. This is what happens. Okay, those who work like retail before, like during your holiday break, then you all might have encountered these kind of things. Okay, this woman here at the cashier there, then go and scold this boy, like, oi, you stupid little. And it's like, money? Okay, like how is this related to electrochem, right? Okay, then there's the second comment below. This very nice customer from heaven. Hey, handsome, here's my card. Blah, blah. And the guy was like, wow, I love you. I mean, I love customers like you. Okay, so the point of these comics are not for fun, not for fun. Okay, but I hope they made your day a little bit. Okay, but from this up, what I want you to be able to see is the selective discharge list is always based on a decision. Okay, so if the customer is being rude to me, do I want to serve this customer here? If I have a choice, I wouldn't want to. But if there are 1,000 of them outside, I may want to. Okay, and this is due to concentration effect. We will talk about this soon. Okay, but whenever a customer is being rude, I don't want to serve them. Therefore, they don't get selectively discharged. Okay, so the ones that I want to serve are the ones that are below here, the ones that are less stable. Okay, so less stable, you can think of it as most easygoing or easiest to discharge. So whatever is below, this is where your reactivity series comes in. Other than the lower they are, the easier to discharge. The relationship that I need you to see here, if you are tested for a reactivity series, always be able to segregate two different things. Number one, when we talk about metals, it's always about reactivity. But when we talk about ions, it's no longer about reactivity, it's about stability. Okay, so ions, as you go down and down and down and down, they get less and less stable. Metals get less and less reactive. That's the difference. Okay, so this is what the comic here is about. Okay, of course, with your idea, with the notes here that's given to you, one glance you can see which are the customers I want to serve, which are the customers that I don't really want to serve. Okay, so for cation side, I won't elaborate too much. Anion side is the a bit tricky one. When I have concentrated solution, I have 1,000 root customers waiting for me outside. Both no choice, I have to serve them. Therefore, concentrated with a concentration effect kicks in. For concentrated solution, instead of serving my OH minus, I serve my halides, OH minus. No longer served, I serve Cl minus, Br minus, I minus. And which one do I serve first? I should serve I minus first. Reason to this, understand this rather than putting this into your head. Periodic table, group 17. Reactivity decreases down group 17. Cl2 is more reactive than Br2. Oops. Therefore, Cl minus more stable. That's why Br minus and I minus will selectively discharge first. Okay? The reactivity series, I think you already get the logic. Okay, so that I'm not too concerned. Okay, so take note, concentration effect should affect the anions. Okay, but cations wise won't. Okay, so to summarize this up, the cations of a less reactive metal undergoes reduction by gaining electrons more readily to form atoms. Done. Okay, so this is the whole idea or the concept behind electrolysis. Okay, of course, the entire chapter, as you would have learned in school, or if your teacher really like very give SLS for you to study electrolysis, then you should have gone through this entire thing in approximately, I feel, 2 to 3 lessons. Okay. I know that the things that we are discussing here is not comprehensive in terms of going down to the deep detail, but these are things that are super important. Going into exam, you need to recognize this. Okay. At this point, question 1 is your first obstacle to clear. Okay, I think this question is pretty straightforward. 30 seconds is all I'll give you for this question. Breakdown of the question here, it highlights I have copper electrodes, my current is constant, and I weigh my anode. Copper electrodes in your head immediately should be reactive electrodes. Okay. Your 30 seconds has already begun. You can go ahead and think about it. Okay, time. Answer to this should be C. Okay, I feel there should be only two possible options, A or C. Okay, you should know for a fact that the anode is going to decrease in size, decrease in mass. Why? Because anode gets oxidized. Again, bring back the animals. My animals are an ox, red cap. If I'm talking about my anode, my focus here should be an ox. An ox, what happens? Anode oxidizes. Not only I want you to know how to solve this question here, if question clicks around and asks you to write the half equation down, be sure that you know how to do this as well. Okay, so when you're studying for electrolysis, don't be contented with like, oh, I go through this question, I understand, go on, go on, go on, go on. Okay, if you want to like truly improve and like level up, right? In this question over here, you should be telling yourself, oh, copper. Copper becomes what? Cu2 plus. How do I become Cu2 plus? A lot of you I know hate the electrons one. Like, why the electrons for what? Electrons are actually meant to balance the equation for you. Don't hate it, use it to your advantage. My equation here is not balanced in terms of charges. Left side is 0, right side is 2. Therefore, I add electrons on the right side to balance out the charges. Okay, that's why the electrons is written on the right side. Therefore, copper lost electrons to become Cu2. Okay, later we'll talk about the color stuff, but we go on to question 2 first. Okay, question 2 is very, I would say a standard question, and I got a lot of extension questions that I want to check with you here, okay, or rather for you to think of. Okay, I think it's question for me to like pinpoint people to like answer my questions. Okay, but think about this question for, okay, I think 30 seconds also can, because no calculation required here. Okay, try. Might as well make your time worth it. Key breakdown of this dilute sulfuric acid, graphite electrodes. "15 seconds to wrap up. Dropping hints here and there. Things that you should be telling yourself should look like the following. All right, so let's go. Question 2. Answer should be B. Okay. Karen and Jingxuan familiar? We did this, right? We did this last week, right? Okay, so the gas involved at the cathode is less dense than air. Why? At the cathode, who will be attracted to the cathode? Cation's customers go and visit my cathode. H plus is the only one. I don't even have to make a position. H plus confirm get discharged. Okay. H plus that get discharged must become H2. Okay. Therefore, H2 less dense than air, confirm true. Why? Mr of H2 equals to 2. How do I tell whether it's less dense or more dense than air? Air is Mr equals very good. I love to trigger your thoughts because you all really know. Okay, Mr is 29. Okay, so less dense 2 is less than 29, therefore really less dense. Okay, I feel if you didn't get this question, you may have chosen C as your answer. Okay, so the gas evolved doesn't relight, but rather it extinguishes. Sorry, for this relighting or glowing spin, it should be oxygen gas, so it should be at the anode instead. Okay, if we focus on the anode side of things, right? These two go to the anode. Who gets selectively discharged? Based on your customer VIP list, OH minus is the most easygoing customer. I discharge. I serve that customer first. OH minus gets discharged. That is when the usual standard equation comes about. Okay. Same thing as I want to recommend you here. If you want to improve and level up, force yourself. Even doing MCQ, I know how shared it is. Okay, force yourself to write down the equation. 4H minus therefore forms O2 to become oxidized. Therefore, anode oxidation takes place, cathode reduction takes place. Okay. My question to you as an extension is, what happens to the concentration of the electrolyte in this? Whenever I discharge H plus and OH minus is known as electrolysis of water. Whenever this happens, electrolyte becomes more concentrated. What happens to the pH of this solution? Okay, so these are multiple things that you can keep questioning yourself with. Okay. So in your head, I think you have some answer. Maybe some say don't change, some say increase, some say decrease. pH actually will drop. Why? Because it's an acid solution. If acid becomes more concentrated, the pH will become lower. Right? So this is just extension. Okay, I won't elaborate further to this. Let's go to question 3. Okay, question 3, I won't let you try this. Okay, question 3, I feel it is either you know or don't know, so I rather introduce this idea to you. Whenever we do electroplating, we need to ensure that electrons are able to flow. Therefore, if we are trying to electroplate a non-conductor, we need to plate it, we need to coat it with a conductor first. Okay, so whatever you do, if you put fine metal or carbon, we need to provide conductive surface. Okay, same thing if you link this to chemical bonding, going forward to your prelims, to your O levels or what, these carbon particles, you need to be able to convince yourself that this cannot be diamond. Why? This must be graphite. Okay, because graphite is the one that can conduct electricity. Okay, that's for question 3. Pretty straightforward. Question 4 is the one that I want you to try this out. Okay, because this kind of mole X electrolysis question is famous, and I want you to be able to solve all of them going forward. Question 4. If you don't have a periodic table, the AR of silver is 108. If you need it. Okay, if you feel you don't need it, it's fine as well. Well, this one cannot go away. Give this a shot. About 1 minute time to discuss. Okay, for those who, if you don't know where you want to start with, you can try to write down the equations first. At the end of this question, there is a super important relationship that I want you to bring home. The light is at the side. 30 seconds to wrap up. And time. Okay. For questions like this, where more X electrolysis, questions need to give you some form of info for sure. Okay, question gives you mass, definitely you can calculate MR. Therefore, AR of silver 108, I can calculate MR to be, I can calculate moles to be 48 over 108 moles. Okay, what can I get from this, or what do I do next? Okay, mass divided by AR common give me my number of moles of silver. So why do I say you need to write the equation for yourself to see? Because this happens. Ag plus 1 electron can already form me silver metal. However, for aluminium, the following happens. Al3 plus requires 3 moles of electrons. Then I can form 1 mole of aluminium metal. Okay, the relationship to take away is below. We will conclude at the end of it. But maybe some of you already see the relationship. Okay, but what I want you to be able to put into this question here, right? 408 over 108. Can I have the answer? 0.4444. Okay. 0.44444. Okay, with this 0.4444 formed, okay, how many moles of electrons am I using? Also 0.44444. Why? Because the mole ratio is 1:1. Question tells me I use the same amount of charge. What does this mean? I use the exact number of moles of electrons for aluminium as well. Therefore, this 0.44444 carries forward to here. How much aluminium can I form? Is it still 0.44444? No, because mole ratio is 3:1. Therefore, I divide by 3, I should get 0.1. 14814. Is it? Okay, thanks. Okay, so I need you to understand the method to this. With this calculation of the number of moles, then I can find the mass rate. Okay, so I can use number of moles multiply by AR. Okay, and I should arrive at 4 grams. You good? Okay, so these questions where mole meets electrolysis are getting common. Okay, they are appearing in TYS as well, past year papers. So it's not just limited to prelim papers. Right? I think for my students, we have tried this kind of question quite a number of times. So the relationship you take away, you should be thinking about it, Karen and Jingxuan. and Jingqi joining online also, right? If larger the charge of the cation, the more or the less amount of metal I can form. The less. Or the smaller the amount of metal formed. Okay, so the relationship is if I need more electrons to discharge, I only can form less of that particular metal. Okay, so this relationship, like the question doesn't ask you for this relationship, but the relationship to take away here is you can check your answers quite effectively for this. Okay, so from here we can prove this as well. Here, see aluminium, I form much less compared to silver. Okay, let's go. Question 5. Who's the button? Oh, the structured question already. Wow, okay, we are quite on time. Okay, for question 5, for part A, I'm going to force you to write the equation here, okay, rather than revealing to you the answer. Okay, because I think 10 seconds, majority of you can finish writing this equation. Okay, or if you are not familiar, then you need to force yourself to write these equations. Okay. Breakdown of this question, for those who are not sure yet, equals potassium hydroxide, K plus, OH minus, H plus. Graphite electrodes, inert. Okay, so over at the anode and cathode, question yourself, which one will get selectively discharged? Fifteen seconds to wrap up. Part A. Okay, part A. Ionic half equations at the anode cathode, pretty standard. Okay, so many people can write this. But part B, people will start to struggle with the explanation. Okay, so these two equations are pretty standard. But what I need you to be able to see from this as well is one only requires 2 moles of electrons, but the other needs 4 moles of electrons. Okay, so this will affect your mole ratio or your amount of gas being formed. Okay, which is what the question actually shows you as well. 40 cm cube and 20 cm cube. Okay, I'm producing different volumes of gases. Exactly how do I explain this in terms of words here? Okay, for part B, explaining why the volume is twice at the cathode compared to the anode. Okay, immediately what should come into your head is, I've learned this. I know I can sort of rewrite this equation as this. When is the time for me to safely compare mole ratio? When the electrons are exactly the same. Why did I multiply by 2 for this? I want to make sure electrons, same number of moles. From here, then it is safe for me to compare 2H2, 1O2. That's why I'm going to get 2 moles of H2, 1 mole of O2, Therefore, volume is twice. Okay, but exactly in terms of electrons, how am I going to explain this to the examiner? Okay, you need to explain for sure in terms of electrons. Okay, so answer to this, again, don't be obsessed with copying the answer. Understand how you come up with the number of moles each electron. Okay, how many moles of electrons will be gained by the H plus? I need to gain all 4 moles of electrons by the 4 moles of H plus. How many moles of H2 will I have? 2 moles. Essentially, what am I doing with this first line here? I'm trying to explain my equation. I rewrote this equation here to remind myself. The 4 came about from here. I believe it's a scam call. Got too many scam calls. Okay, so with this 4H plus 4E minus, that's why I can safely write this into my answer here. Then I form 2 moles of H2 at cathode. Okay, over at the anode, I don't really want to review to you this anymore. From the equation, can you try to fill in the blanks for the pink color spots? How many moles of electrons are being lost by how many moles of OH minus to form how many moles of oxygen? Okay, think you got the idea? It should be 4 moles of electrons as well. How many moles of OH minus? 4 moles to form only 1 mole of oxygen. Okay, key takeaway. Okay, again, answer key is still provided. I need you to be able to convince yourself why it is important to write in terms of electrons. Okay, because you may be able to come up with this blue color equation here. Are you able to code correctly the amount of electrons and the amount of gas being produced? Okay, extension question is C. Okay, I want you to think about this. If the student sets up 2 more experiments, molten as well as concentrated, we know things will change for sure. Okay, but when question wants us to describe the differences in the products, that's where some of you will struggle. Okay, we know that the difference is going to be very different for the molten potassium chloride. Molten stands for liquid. Molten means I have no water. Therefore, potassium chloride, K plus, Cl minus. Concentrated equals potassium chloride is K plus, Cl minus, H plus, OH minus. Same. Okay, but concentration that kicks in here. We know that for concentrated solution, Cl minus will get selectively discharged. H plus will still get selectively discharged. Over at the cathode side, or rather, sorry, the molten potassium chloride side, no choice to make. I only have these 2 customers. I will serve both of them. Can you see where the difference is already? If you choose to write about the anion getting discharged, it is going to be the same. If question gives you to write the differences and you choose to write about the selective discharge of Cl minus, no marks will be awarded to you. Okay, so the breakdown of the question in terms of ions are important here. Note down the ions that you have first, then you decide, oh, Cl minus seems to be the same. The difference is K plus versus H plus. Therefore, the first difference is going to be concentrated, I form H2. Molten, I form potassium metal. The second difference is the one that I want to emphasize on. So when you run out of differences to write, go to your electrolyte. Because your anode, you're going to see the exact same thing. So the only other difference is at your electrolyte. Whatever that gets left behind will be the product of your electrolyte. Therefore, at the concentrated solution, my end product of my electrolyte is going to be whatever is get left behind here, K plus, OH minus. That's why I form potassium hydroxide. For molten potassium chloride, K plus, Cl minus, as I discharge them, I am going to form KCl of a lower volume. I use up the K plus and Cl minus, I will just have less and less and less of molten potassium chloride. Okay, so point to take away is not really again on the answer key, but when you run out of differences, go to your electron. Okay, that's the main point I want you to take away. Okay, let's go. This is last question, electrons. Okay, question 6. We have 2 more questions for electrolysis. I see how. We go into this question first. This question is very, very interesting. Okay, same thing. I don't want you to, I won't go through every single part of the calculations. Okay, but rather than you trying the questions with 5 minutes, we break down the question together first. I let you try it. Okay, in this question, I have 2.5 grams of copper 2 sulfate. Okay, we are always, as students, very scared of this dot here. There's nothing to worry about this dot here, apart from the fact that, number 1, this is hydrated salt. Number 2, when I calculate the MR, take into account the H2O. Okay, so this dot over here suggests to you that you need to ensure 5H2O is inside the MR if you need to do any form of mole calculations. Okay, I dissolve this in 2 DNQ of distilled water. Electrolysis, copper 2 sulfate, platinum electrodes. Okay, copper 2 sulfate is a very common thing that they like to ask. And what you should expect the question to be asking is, what happens to the color of the solution? Okay, because you know copper 2 is blue color. Okay, we will see the questions later. Okay, think of part A first. The graph of the change of mass of cathode is as such. Number 1, understand why there's an increase in mass first. Why would there be an increase in mass? It can only be because metal is being deposited. If I have a gas being produced at the cathode, the gas will escape. The cathode will not increase in size. So this graph over here already suggests to you that metal deposited at cathode. Okay, so these are simple breakdowns that are going to go a long way in your analysis of the entire question. Okay, and trust me, electrolysis is perfectly possible and you should be aiming for fluence. Okay, it's the data question that we won't get focused on. Okay, there will be certain questions that we don't know. It's fine. Okay, but this kind of question where we know, we must get it. So half equation for the reaction occurring at each electrode. I have copper 2 sulfate, which consists of Cu2 plus, SO4 2 minus, H plus, OH minus. 1 minute for you to try to write down the ionic half equation. Okay, because this will determine your entire question. If you are unable to decide which one we will choose to serve in my customer VIP list, go back to what we have discussed in the notes before. Okay, you have that VIP list with you on top here. So, okay, you can use this to try to decide, hey, which one should I discharge? Thirty seconds more. Okay, half equation, therefore, at the anode, if you have correctly identified who will get selectively discharged, most likely you will get this correct. Over at the anode, OH minus should get selectively discharged. Cu2 plus should get selectively discharged at the cathode. Okay, so anode-wise, straightforward. Cathode is the one that we always mix up. Okay, so you really need to question yourself, oh, Cu2 plus, H plus. Then I go down my reactivity series, whatever acronym that your school uses or your tuition class uses. Okay, for ours, it's the zombie one. Okay, so for the cathode, it should be Cu2 plus becoming copper metal. Okay, whenever you are doing practices like that, things that you should be telling yourself is, oh, at the cathode, I expect to see reddish brown deposits. I expect the cathode to increase in size. Okay, so writing down the half equations, yes, true, you will level up. Okay, but how to level up even more? Always question yourself, what is the observations? Okay, even if the question doesn't ask. Okay, part B, I don't want to jump too much into it. It's more of more calculations for this. Okay, so this one, refer to the answer key for a bit more. Okay, but for the molar concentration, as what I was warning you, just take into account 5H2O, you're going to be fine. Okay, I have the mass, I have the MR, I calculate moles, I divide by 2, I can get the molar concentration. Okay, I won't discuss too much into this. Okay, because focus of today not really of mole concept. Okay, but the concentration you should get is 0.00500 mole per dm cube. Okay, so if there's anything to take note of in this 250, tell yourself that MR needs to consider 5H2O. That's it. Okay, so I won't elaborate too much. Part C as well. Number of copper atoms formed, just a brief one. Just want you to be aware of how you can write down the number. Okay, it's something that we hate. It's called Avogadro's constant. Okay, but without Avogadro's constant, instead of writing MOL, we are going to be writing 6.02 times 10 to the power of 23 every single time we need to calculate in terms of moles. Okay, so don't hate that guy too much. Okay, although that guy's name can be a little bit shorter. Okay, but it is meant to help us. Okay, so this one is really when you calculate the exact number, you need to multiply by Avogadro's constant. Okay, so same thing, I won't elaborate too much as well. I will go on. Okay, concentration after 10 minutes. Yeah. Part E is the one that I want to elaborate. Okay, so 6D as well, I will zoom past. Okay, concentration after 10 minutes. I will refer you to the answer key for this. Okay, but what I really want to take away is E. Okay, and I want you to think about part E for 20 seconds. What happens to the change in the appearance of aqueous copper 2 sulfate over time? Okay, in electrochemistry, very, very famous question. Okay, and I'll give you the exact keywords that you need to include. Okay, because electrochemistry is all about the keywords here. Ready? Okay, I hope you have thought about it. Okay, because it's important really. Okay, before I give you the answer. Okay. Again, don't worry about the working for part D. Okay, we go into part E. Okay, before we even look at the answer, first thing to question yourself is going to be copper 2 sulfate initially what color? Ooh, blue color. Therefore, when we encounter questions like this, it's either, oh, the blue color fades, the blue color remains, or maybe even the blue color becomes gold. Okay, so this is how we can expect the blue color to change. For this particular question, we have written down the equation here. Over at the cathode, Cu2 plus becomes copper metal. Therefore, inside my electrolyte has a lot of Cu2 plus initially. But then some of them went over to the cathode, then they gonna discharge. Therefore, Cu2 plus is going to get lesser and lesser and lesser and lesser and lesser. What do you expect the color of the solution to change? Thick. Okay, so this is how your thought process is going to be. Okay, because there's nothing to replenish my Cu2 plus, my color can only fade and fade and fade. Therefore, the blue color of the solution will fade. Okay, so don't need to write fade and fade and fade and fade. Okay, so fade in blue color, eventually, after a long time, because they are saying over time, for quite a long time, if I keep letting the electrolysis run for a few hours, we expect the entire solution to become colorless. When will this occur? When all the Cu2 plus get selectively discharged. Okay? Because Cu2 plus is so unstable that they can get discharged very easily compared to H plus. Okay? Keywords for this. Some of you may recognize this already. Okay, but I need you to be able to tell the examiner why. Okay, questions that you expect to see are describe and explain. How do you explain this very effectively? You need to tell the examiner you understand who is getting discharged. Cu2 plus, selectively discharged. Add on the keyword here, selectively discharged. At the cathode, always link this to super important keyword here, concentration. You need to tell me what happens to the concentration of the ions, then tell me how the color changes. Okay, so it's quite obvious here at this point, I feel. The Cu2 plus is going to get less concentrated, concentration drops. Therefore, blue color fades. When all become discharged, colorless. Done. Okay, the only time when the color will remain blue is when I have copper anode. Okay, so side note here for yourself to think about. Side note, if anode is copper, Cu2 plus can get replenished. Blue color remains. Okay, this is another potential question that may come out. Okay, so if you can cover all grounds going into exam, you don't need to like on the spot think about it again. Okay. Let's go. 6F. Okay, the mass of copper deposited does not increase after 30 minutes. Because what have we established? It has all gonna selectively discharged. No more Cu2 plus in the solution, but then there's still oxygen gas being formed. Only logical explanation to this is no more Cu2 plus, but there is still OH minus getting selectively discharged. Okay. This question can vary in terms of the way that they're asking you. Okay, so I won't jump into this too much. Okay, but the key idea here to question yourself will be, when question asks me things like that, why I don't deposit anything anymore, does not increase. Things to take away from this will be, no more of the cation. Volume of oxygen continue to increase because there is still got OH minus. Okay, English a bit broken here, but you get the point. Okay, so these are the thought processes that you should have. Okay, so long story short, this means all the Cu2 plus discharged, but I still have OH minus ions, therefore I still can evolve oxygen gas. Good stop. Okay, I want to spend about 5 minutes going into the simple cells where we try to calculate the exact value of the voltmeter reading. Okay, answer key shall be provided for you. Let's go. Sorry, do you see this as question 6 or question 7? 7. Okay, well, on my end, we never update this. Okay, question 7. This is question 7. Okay, simple cells. Simple cells, the hardest thing that people find is how come sometimes the voltage I see positive, sometimes I see negative. Okay, that is the question's responsibility to tell you. Okay, so question will give you hints here and there for you to decide whether it's positive or negative. No matter whether it's positive or negative, the value is always going to be bigger when the reactivities are very far. That is the fact that will never change. Okay, so with this, quite simple. I have copper, iron, zinc. Question gives me this exact thing. When do I see positive? When electron flows from metal 2 to metal 1. When electrons flow this way, this gives me positive reading. How can this occur? When metal 2 is more reactive. Remember, the more reactive person got gun will shoot. Metal 2, more reactive, shoot out the electrons. Okay, so metal 2 will be more reactive, then I will see positive reading. $10 for each row for you to fill this up first. Okay, I think this is highly relevant. I think you should get this pretty easily. Try this out. Okay, even if you don't get it, it's fine. We will go through exactly why. Okay, first answer, 100% of you will get it. Iron. It's same metal, no difference, no voltage. When do I get a positive reading? When metal 2 is more reactive. How is metal 2 more reactive? When it's zinc. Okay, therefore last one, copper. Straightforward. The prediction of the voltage is the one I want to emphasize a little more on. Okay, but for 7B, we go through a little first. Negative electrode must be the more reactive one. Negative electrode, always tell yourself in simple cell, more reactive metal. Okay, so explaining in terms of direction of electron flow, so metal 2, if I choose one of the pairs to talk about here, the iron-zinc pair, I am sure that the electrons are flowing from the zinc into the iron. Therefore, the zinc is the negative electron. Okay, the one that I feel will come out for WA2 is the calculation. Okay, so how do I or how do I calculate the exact value? Okay, part C I won't go through. Okay, but zinc is getting oxidized to form Z2 plus. Okay. Part D, what you observe. So in terms of observations, okay, this is something worth mentioning. Observations, if you hit this kind of questions, there are three things that you can question yourself for. Number one, is there any effervescence? Number two, is there any color change? Number three, is there any PPT or solid formed or dissolved? Okay, so if you hit questions like this, question yourself these things as observations. Observations must always be things that you can see. Okay, so you cannot be telling me things like, I see copper metal being formed. The examiner will be like I don't know what is copper metal. So what exactly do you see? I see red-brown deposits being formed. Okay, that is the observations you need to write. Okay, so for this question, what do you see? You see zinc electrode decreasing in size because anode is being oxidized. I see zinc being dissolved. Observation 3 is the one that I could apply here. Okay, so zinc anode becoming smaller in size because it oxidizes. Prediction of voltage wise, this one. Okay, how can I predict the voltage accurately if I have copper, iron, and zinc? Okay, whenever you need to predict the voltage, this is when I don't need you to care about positive or negative anymore. When you are predicting the voltage, take the absolute value in left sense, okay, or simply take the numbers. Okay, so between I have iron and copper, 0.10. So between iron and copper, 0.10. Next, I have iron and zinc, 0.60. Iron and zinc, 0.60. If you draw this out, then suddenly it becomes very easy. Predict the voltage when zinc and copper are being used. Can you see? It's going to be 0.70. Okay, but the tricky part will be, do I need to write positive or negative? Again, this is the question's responsibility to tell you. I told you if metal 2 is more reactive, I see positive. Currently, metal 2 is less reactive. Therefore, I see negative. Done. Answer, negative 0.7. You good? Okay, so this is a summary of electrolysis. I won't go through the very last one. Very last one, you can apply the exact same idea that we have discussed. Don't need to be too concerned about negative and positive when you are seeing how far apart they are. Okay, so I won't be running through this. Rather, the last 2 to 3 minutes, I'm going to sum up ammonia using like a factory idea. Okay, because ammonia people kena S like kena arrow for SLS one. Okay, so for ammonia, ooh, got blanks to fill in. Okay, but before we fill in the blanks here, right? The idea to this page what? Page 31. Idea to this for the whole Haber process, understand why low temperature versus high temperature is going to lead me to differences. Okay, if I'm trying to produce like iPhones, then I force my workers to work in a very very hot place. How will they work? They'll work then fast. I want to produce all the iPhone, but then the iPhone that they produce are going to sit. Therefore, high temperature rate of reaction fast, but the yield very very low. So Haber process I cannot have too high a temperature. Why? Because my yield will be very low. So if I put them all inside aircon, then we were like, oh shoot, I can make the iPhone like slowly make to the best of the quality. The yield will become high. But how will they work? Aircon chit chat with my friend, I'm like, hey, your iPhone how? Okay, so the rate of reaction will become very, very low. Okay, so the whole idea of Haber process, they like to test this inside MCQ or some structured questions. Temperature high is rate of reaction high. Temperature high, yield becomes low. That's the idea behind it. Okay. Next thing they like to ask will be this. Okay. Where do you find the respective things from? And the conditions that you need for each of it. Okay, so this one won't elaborate too much, but the source is something that people will mix up. Nitrogen is from fractional distillation of liquid air. Hydrogen is either from crude oil, cracking, for those who have learned organic chem. Electrolysis of water also can. Electrolysis of water is expensive method. Cracking of crude oil is non-renewable, therefore not very sustainable. Okay, so it's not so easy to get hydrogen like how we imagine. Okay, then the conditions, sometimes they will ask recall question, okay, but not very often. Okay, but we must still know the conditions for sure. Okay, so 450, pressure, you write 200 or 250 are both fine. Okay. Catalyst will be higher. Okay, and the factors we have talked about, so the low temperature, we want to ensure that the yield is still sufficiently high, but cannot be too low because rate of reaction will become too slow. Okay, so to have high yield, I need low temperature, high pressure. Then question will throw 1 to 2 mark question, ask you, how come we cannot have too low a temperature? Because rate of reaction too slow. Longer production time. Then how come we cannot have super high pressure like 1000 atm? Because dangerous, because expensive. Okay? So greater risk of explosion and expensive to maintain the high pressure. Okay? So this is the ammonia chapter like summarized quite quickly. Okay, so these are potential things that they can test. Okay, questions wise, we won't run through. I refer you to the answer key instead. Okay, but I just want to give you a wrap up of today's session. Okay, so to reiterate the important points, I definitely feel that energetics and electrochemistry are harder. Okay, ammonia, if you know all these things, you go into exam, you are going to be fine. Okay, but electrochemistry wise, energetics wise, just to reiterate again for energetics, system and surroundings, you need to get it right. Okay, you are at a stage that is like you are building up to O levels. Is there still enough time? Yes, there is. Okay, but are you quite screwed if you don't understand anything that I said today, like zero? You are. Okay, but I'm 100% sure that you are not like 100% clueless of it. Therefore, you confirm got enough chance and time for you to live. Okay, after finishing the syllabus, of course, you need to PR the papers, not just by doing, and just throwing them aside. Okay, analyze the question, break down the question, level up yourself. Okay, by questioning yourself about every single thing, whenever you do electrochemistry questions going forward now. Okay, don't be happy getting the answer. Be happy after you question yourself. This and this and this will change even after I answer the questions. Okay? Energetics wise, remember put your BB before your PM. Okay, the calculation question most likely will appear in the WA2. Okay. Okay, I don't know whether you all attended other revision sessions or not. Okay, but at this point, if you can help me do this, I think it will be great. So scan this QR code. Okay, scan me. Okay, this like feedback for this WA2 revision session. Okay, I honestly hope that it helped you out. Okay, whether how little or how much that it affected you. Okay, my name is Gerald, by the way, if you cannot remember already. Okay, so for these 2 hours, I didn't say my name again. Okay, but I hope you remember my name after this. Okay, for people online, can you help me to do this as well? Y'all can see this screen, huh? Let me just check. Can. Hey, can you help me to scan this QR code and help me to fill in the form also? And my name is Gerald once again. Okay. So there are some pictures of me at the side that we can have your own viewing if you want to. Okay, before you go, let's take a picture, okay? I wanted to take a video of y'all like being very serious when y'all are like trying the question as well. Oh yeah, answer key. You can be very honest about like I feel just be here for 3 hours. You just when I see you. Wednesday. Really. I'm supposed to be you need fill in the form that I entered the correct. Okay. You must trust that you have filled in the correct table. You fill in the correct table. I think I trust that you fill in the form for me. Yeah. Okay. I don't think you need. You need it. Take the back. Okay. How many bags from my parents? Run. Really? Okay. So. Really? You have really? Okay. Who's the Clara? Is that example? Oh, yeah. Yeah. What's your name again? Oh, I think I saw like followed by carrot. Oh, okay, can. Okay. Anyway, thanks guys. We'll conclude here. Thanks for filling out the form for me. Okay. I wish you the best for your WA. If you are existing overmarked students, then I will still see you around. Okay, but if you are not and you are keen to join, don't need to message me because I don't you know my number. So you can message the admin if you are looking to join. But I genuinely hope that this WA2 event helps you along the way. If I am glad our paths crossed. Okay, well, I'm a very emotional person. I was even at 10 p.m. just to talk to you. Okay, let me think if I have anything else. Wait, I need to take a picture with you. Please show me your faces. Okay, come. People joining online, would you like to turn on your camera right now? Then we can take a huge group picture together. Let me see who is online. Wow, my students are so happy. Ziting, Johan, Simon. Ooh, hi Johan. Ooh, Ruby. I think Ruby is my student if you are the correct Ruby. If I was not my students already, I said. Okay. For those who just received this from me, right? Can I trouble you to change something or note down something that you need to change? Because the trend that you see on the periodic table, right? The keep reducing the okay. All this is already changed. Selection power decrease. Color intensity, nothing one. Great. The small selection decreases. Okay, sorry, then nothing to change. Because this is already a new set. We are good. Okay, because the previous one we got a minor error, just wanted to flip the arrow around. Okay, but we're good. Let's take a picture then. Want to help me take a picture? I want my face to be the smallest possible. Who am I kidding? You're so nice. Oh my. Okay, 0.5. Thank you very much. Okay. Volume button, I think can. Anyway, I think you should take from the back so that you can see the bird. Can I trouble you to take from the back? Okay. Yeah. The volume down. Yes. Yeah. Take one from the back and take one from the because I think from the front I can see everything like nicer. Okay. Uh, I think you take from there, can? Yeah, that one, so that I can still do so. Thank you. What's your name? I will tell Daryl that you are very nice. Daniel. After I say he nice, then you go and kick me first one. Okay, pose guys. Hey, make sure you can see everyone. If cannot, then no one will be going home tonight. Check. Are you believing me? Sorry lah, my handphone lost. Okay, one. Sorry, soon before then you won't be here. Okay. Okay, not bad. Hey, but I don't even post. The only shot that you got that was good, I wasn't even posting. I was like, okay, I'm gonna take one. Okay. Okay, before you post, sorry. WA more. Okay. Two. But I'm not a approval for not pressing the volume. Okay. I think I should have done it. Sorry, one more. Two. Okay. Reverse. Okay, we're done. Thanks, guys. And thanks for your suggestion. I think it makes sense. It needs to be further. Okay, all the best for WA2 for people online as well. I will see some of you for my students. For the rest, all the best for WAs. 加油, bye bye. Bye. Yeah, this is updated. I just need to change arrow only. Okay, sure. Oh, when I'm supposed to scroll the thing for you, right? Your second one? Okay. Can I have a picture of you with you? Take a picture with me? Sure. Where? I have to post on my list. Oh, okay. But I need to accept you, then you can check me. Wow, I'll be very touched to see. Are you an overmark student? Oh, okay. I thought you were Daryl. But you can, boyfriend. What's your name? What's your shit? Okay, Grant, I leave it at this page. You can take down the notes if you need to. Okay, for the recording, I'm just gonna leave this here. Scroll through a bit so that you all can view it. Okay. You're very tall, eh? I feel very inferior. If you feel that, I'm kidding. Please don't. Please show your hand. Show off your hand. Come on. But do you have any notes for practical? Practical, we have it. Yeah. Is it here? Huh? No. Is it there? Oh, yeah. Supposed to give out punch. No, this one not part of the practical notes actually. So this is you can take one of that. Is last year the revision actually we gave out that to you lah. But if you want other subjects, you can take one. Yeah. For practical notes, we are keeping it for our students. Oh. So sorry. You can see Karen actually at last year.
So, I did go there.
Yeah.
Later. Tomorrow. The final one. Oh, you are
You just killed it, Tushan. Good job. I got ready for the test on Friday. I was very excited when I was creating the test. Huh?
Can you show how
Was going
like sneak peek?
sneak peek.
Review.
Sneak peek. Bye bye. Sneak peek. Okay, bye bye. Yes.
Yeah.
More or less confirm. Bye bye. No problem. Bye bye. Your friends like CML or
Your birthday.
one of their birthdays?
Yeah. Then a bit sad. Hopefully you're practicing for WA.
But I have no other options really. What's Monday, Tuesday, unless Tuesday night. When is your paper? Which is Tuesday, is it? On Monday.
It's the thing that our Monday.
Yeah, cause cannot really. Tomorrow, Friday, Saturday, I'm involved the whole day. Yeah. So Sunday is my best time.
Okay.
What time?
I'll tell the group.
Okay. I'll send you all the info soon.
Okay.
But it won't be like very, very long. I just want to make sure that I'm still recording these shots. Yeah, it's not very